This is a video looking at finding the coordinate for the center of a circle and the radius. Before we start, let's just reconsider the definition of a circle, and we define a circle as a locus of all the points r distance away from a center. And if we connect all the dots, we end up with a circle. The general form for a circle is, the standard form rather, is this equation here. And this tells us straight away the coordinates for the center and the radius. The general form is written here. Now the general form, you can find the center, but you can't find the radius. So you'll need to do some work for the radius. If you multiply the coefficient of x by -½ and the coefficient of y by -½ it will give you the center. And I've just included the formula for the equation of a circle with center at the origin. And I've drawn a circle here on the Cartesian plane, and as you can see, the circle cuts the Cartesian plane into two regions, outside and inside the circle. We define the radius as always greater than 0. We take the magnitude, although we can see here that we've given the radius as a coordinate, but we only consider the radius as positive. Let's have a look at an example. Example 1, find the center and radius of the circle x² + y², subtract 1. Okay, so let's just use a method. Firstly, by considering the coordinates of the points on the axes. So this is the x-axis, this is the y-axis. I think you can all agree that y is equal to 0 all along this axis, and x is equal to 0 all along the y-axis. So let's consider what happens on the x-axis when y is equal to 0. Okay, so we're going to get x², which is going to get 0 for the y, subtract 1. This is called the difference of two squares. We can factorize this, and we can see that the circle cuts at -1 and +1. Let's do the same for the y-axis. And we can see that the circle cuts at 1 and -1. We can draw our circle in. A good circle. Okay, so that's the best circle I can draw, and we can see that the radius by inspection is 1, and this is referred to as the unit circle. However, there are conditions where this method doesn't work, and I'm just going to go over those very briefly. Let's consider a circle which doesn't cut any axes. So the solutions would be imaginary. Do that very quickly. Okay, so we would have maybe a circle here. Okay, so this circle doesn't cut the x or y axes. So we need to consider a different method. Okay, before we do that, let's find the center of each equation in standard form and the radius. I'm going to do the first one. Center is going to be negative half, positive. Okay, pause the video and have a go at doing 3 and 4. Okay, so hopefully you've done that now. So we have the center 2/3, -8, and we have the radius of 12, which is 2√3. Here we have a radius of alpha. We have a center of alpha, -beta, and we have a radius of gamma squared. Take the square root of that. We get a radius gamma. Okay, so this picks up on using another method, and considering the previous slide, recognizing the limitations of the previous method which we used. So we need to move from general form standard form. As soon as this equation is in standard form, we can deduce straight away the coordinates of the center and the radius. And I hope you can all recognize that a method of converting general form to standard form is completing the square. Okay, so let's do that. We're going to add on half the coefficient of x and square. Because we've added on half the coefficient of x, we're going to subtract half the coefficient. Then we add on half the coefficient of y, subtract half the coefficient of y squared, and we've got plus 1. Let's tidy this up. And I hope you can all see by inspection that we got a center of coordinate -2, -1, and a radius square root of 4, which is 2. Okay, so I would like you to find the coordinates of the center and the radius of this circle in general form. Okay, so hopefully you've done that now. So let's have a look. So we need to complete the square. So let's do that then. So we get x. We're going to add on half the coefficient of x square, subtract half the coefficient of x squared, add on half the coefficient of y, subtract half the coefficient of y. Let's tidy this up. I hope you can see by inspection that the coordinates are 1, -3, and we've got a radius, the square root of 9, which is 3. I hope this helps.